As we build our Sodoku solver as a native Java application using OpenJFX or OpenJavaFX, we have created a basic user interface and we've created a representation of our board. Now what we want to do is we want to create the solver class, the class that's going to do the recursive backtracking. And what we're going to do is we're going to just build some testers to test whether or not our board is valid, and we'll put that within our solver. So we'll create a new class, and we'll call it solver. And it won't have a main method because it's just a utility class. And in solver, we'll go ahead and create a constructor. And what will be handy for us is to have a set of numbers that we can use over and over again in order to test our different components. So we're going to make a set of integers that has one of each of the valid numbers that we have available to us. So we'll create an instance variable called checker. It'll be a set. We just want to use a standard Java set. And in our solver, what we're going to do is we're going to initialize that. We'll say checker equals new hash set integer. And we need to include that as well. And then into that, we are going to put 9 different integers, 1 through 9. So we'll see checker.add. We're going to add 1. And we're going to add each of the numbers one at a time. Okay, so now what we want to make sure that checker has all the different numbers in its set, so 1 through 9. And that's just going to be something private that checker is going to use internally, so we'll make that private. And now what we want solver to be able to do is we want solver to be able to look at any given board and determine whether it's a valid solution or not. So let's start by having solver have a method that checks whether or not a given board has a valid row or not. So let's see, we'll call it, it will return true if it's valid. So we'll say valid row, give it a particular row that we're interested in. We'll give it a board we want to check. Board we want to check, and a row that we want to check as well. And that row is going to be an integer. All right. And so what we're going to do is we're going to go through and first we'll make a copy of the numbers. So we'll say set integer numbers equals checker. Let's say new hash set of integers, and we'll start at the checker. So we'll make a copy of that. All right, and what we're going to do is we're going to go through the row, and we're going to make sure that the number that we're replacing, the number that is in the row, is in our set, and we'll remove it one at a time. And if it's not present, then we'll know that someone tried to, we have 2 of the same number in the row. So we'll go through and we'll make a loop that goes through the columns in a given row. Well, C is less than 9. We'll do C++. And then we're going to say, okay, let's, from our board, let's get column C, row R. So we're looping through a particular, looping through the columns in a particular row. And the board is called B, not board. And we will get what's returned as integer I. And we'll say if n contains I, then actually if n does not contain I, that means that we've already removed it, and so return false, because what that means is it means that a number has showed up twice in a particular row. Otherwise, if it does contain it, we'll say n.remove the integer that we just got. And if we're able to look at every one of the columns, if we're able to go through each of the columns, and we're able to remove an integer one at a time, and no more than one time, then it's valid. So then we'll return true. All right, so that should check a particular row. All right, so for that to be true, we need to, or for us to have confidence in that, we need to test that with the jUnit test. So let's go ahead and make that public. And let's come over here and add a new jUnit test. solver test, good. And what we're going to test is we're going to test valid row. All right, so in order to do that, in order to test it, we'll need to create a new solver. Call that S. So that's going to be an example of what we're going to work with. And we'll create a new board, B. That's going to have empty values. So then what we're going to need to do is we're going to need to do some possible examples. So here's our first example. We'll work with row 1, and we'll say board.set column 0 row 1. And what will we put in there? We'll put in the number 9. Right, so a Sodoku board that has the number 9 in column 0, sorry, we're using 1 based, so column 1, oh, that's a good point. We're using 1 based. What are we using? Are we using 1 based or are we using 0 based? We're using 0 based, so we'll put it in 0, 0. So position 0, 0, we're going to put the number 9, and so what we should make sure that is possible then is we should be able to assert that it's true, that the solver says that for board B and row 0, that should be valid because we don't have any duplicate numbers. We don't have all the numbers, but we don't have any duplicate numbers. Okay. So we're testing whether we have a valid row or not. And so after we have created our solver and created a board, we're going to set position 0, 0 equal to 9. And since there's no duplicates of 9, that should come out to be a valid row. So if we run that, we'll see coverage, and it didn't pass. We expected it to be valid, but it was not valid, so there's something wrong with our code. So let's see what happened. We went through, and if end contained an n, we returned false. Oh, I guess we also have to check whether or not it is null, because if it's null, it's all right as well. So if I equals null, let's see, I guess if I is equal to null, then it's okay. So if I is not equal to null, then we check if we have a duplicate number. But if it's null, then it's fine. Let's try that again. There we go. Now we passed our test. So that checked to make sure that it worked when there was 1 number in there. Let's go ahead and continue that check, and let's create a row that's invalid. So let's set column 0 row 1 equal to 9, and let's set column 1 row 1 equal to 9. And this should be false, so we'll assert that it is not true. And we'll run that. And that did not come out true. We expected it to be true, but it did not come out true. So let's just make sure we have the logic here right. Column 0 row 1. Oh, that's because we didn't check the correct row. We need to check in our test, checking row 1 now. Let's run it again. Great, now we've passed our 2 tests. So let's put that aside for a second and go back to solver. And so what we have now is we have something that will check whether our rows are valid. Well, Sodoku, you have to have valid rows and you also have to have valid columns. So let's do the same thing with a column. So we'll copy this code and we'll change it to be valid column. We'll take a board and we'll ask for a column that we're interested in. And instead of going through the columns, we'll go through each one of the rows. We'll get that particular integer. If it's not equal to null, then if our checker set doesn't contain it, then it is false because we've tried to find it twice. And if it is there, we'll remove it the first time. And if we get through all those, then we return true. All right, so that should be check our valid columns. So let's make a jUnit test for that. It's over here so I can see it. So we are going to test whether we have valid columns. Create a new solver and a new board. We'll set 0, 0 equal to 9, and we'll test to see whether it's a valid column. It should be, because there's only one 9. Then we'll set column 1 and row 0 equal to 9, and column 1, row 1 equal to 9, and that should not be valid, because now we have 2 9s in one column. So let's see if we pass that. We don't pass it. Okay, is there something that we did wrong here? Let's simplify this. So let's get, oh, it's actually this one that went wrong. Well, let's just double check that. I'm going to comment out these and see if we pass it without the second check. Let's run it again. Okay, and we passed that. So now let's add this additional check. We're going to set column 1, row 0 equal to 9, and column 1, row 1 equal to 9, and test whether or not, here it is, I called valid row, not valid column. So now when we run our check again, there we go. So we're passing our valid columns and our valid rows. Now we have checked it. All right, that's good. We can check whether one row and one column is valid. Now what we need to do is check whether one square is valid. So this is going to be a little bit different, and it's not a test. We want to check whether we have a valid square. So we'll say valid square, and we're going to want this to be generic, so we'll take a square and we'll give it an anchor point. So we'll give it an anchor column, and we'll give it an anchor row. We'll make a set of checkers for ourselves, and we're going to go through, and this time what we're going to do is we're just going to add 3 each time, and we're going to need a nested loop. So because we're going to check a 3 by 3 square anchored on anchor C and anchor R, we'll go through rows, and then we'll go through columns, check every one of those 3 positions. We'll pull out of our board the spot we care about, which is the anchor column plus the column variable, and the anchor column plus the row variable. And then we just do the same work that we did before, this time checking a square to see whether or not it's valid. So now we can check whether it's a valid square. Let's go back to our solver and write a jUnit test to see whether that's going to work. Test valid square. So now we have a board where we set position 0, 0 equal to 9, and we want to test whether it's a valid square anchored at 0, 0. And we'll run that, and that should be valid. That's good. Now we'll add another 9. We'll put it at position 1, 1. We'll add a 9. And now our square should be false, because we have 2 9s in that square, but they're in different rows and different columns. Let's see if that works. Great. So we now have the ability to check a column, and we have the ability to check a row, and we have the ability to check a square. Now let's build up some helpers for that. Let's, not in the tester, but in the solver class, what we want to do is we want to make something that is public. We'll check all our rows and all our columns. So actually let's build it up here. Public boolean valid all rows, and all we need is a board for that. And we're going to leverage what we already have, so we'll go through and we'll say for each of our columns, we'll say if not valid row b comma, let's see, we're going to go through each one of our rows, not each one of our columns. All right, good. So we'll go through, this is now checking all of our rows. We'll go through each one of our rows and we'll check whether it's valid or not. If it's not valid, we'll return false, but if we're able to get through all of our rows, then we know that we have all of the rows in our board are valid. And we can do the same thing with columns. You can see we're leveraging our code that checks individual columns, and we're going to check to see if all the columns are good. And check whether we've got valid columns. Good. And then we'll do the same thing with our squares. Check to see if all of our squares are good. In this one, we have to go through our rows, but we don't want to check, we don't need to make sure that every possible anchor position, we're going to go through in steps of 3. Because we only want every third position, and then we want to check if it's a valid square, given our column and our row, and r plus equals 3, and we're missing a parenthesis. Okay. And we're missing a parenthesis. Okay, there we go. Now, I don't believe it unless we test it, so we're going to come over here and we'll test it. And we'll say, okay, well, let's make something that tests all rows. And if we do that, we create a solver, we create a board, we put 9 in, let's see, column 0, row 0. We're testing all rows. So column 1, say column 0, 0, 9, column, we'll do 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8. All right. All right, so that put 9 down the main diagonal of our board, and so that should have all valid rows. And let's see if that works. Did we run the right code? Let's see. Good, we checked all valid rows, and it was okay. Now we want to do one in which it's not valid, and so we will take the same thing, and, well, let's see, all we need to do is add one more. So we'll say, in column 8, let's see, in column 7, row 8, we'll put another 9. So now we have 2 9s in row 8, and that should now be false. And if we run that now, good. So we tested a true condition, and we tested a false condition. Now let's do the same thing with our columns. Go through here, we put on the main diagonal, all columns should be valid, and then on column 8, row 7, we'll put another 9, and then that should be invalid. Let's run that one. Passed, we ran the correct code, we ran the columns code, and then finally we'll check whether we have all the right squares. Okay, so for this one we're going to put a 9 in each one of the position in the upper left-hand corner of each square. So 0, 0 will be equal to 9, and we'll put column 3, row 0 equal to 9, and column 6, row 0 equal to 9. So those are the top 3. Now we'll do the middle set. That's going to be at 3, 3, 3. And then we'll do the bottom set, which is at 6, 6, 6. All right, so we'll have a 9 in each one of those positions, and then finally we'll put a 9 in the bottom right, and that should make the squares invalid. So first it should be valid, and then it should be invalid. Let's run that. Oh, I ran the wrong test. Let's do coverage here. Great, and we passed that. So now we know that now we have good reason to believe that we can check whether a square is valid or not. So finally, let me move this over here. And the last thing that we want to do is we want to create in solver class, we want to create a overall board checker. We'll say public boolean valid board B, and we'll say if valid all rows B and valid all columns B and valid all squares, yeah, B. That if nothing, we'll just return that. So if all things are true, then it's a good board. And then I guess it wasn't last. We also want to check if it's full. And that's going to be complete. And so for that, we're going to want to go through each one of our squares. We're going to want to go through R1 through 9. And we're going to want to make sure that if b.get c, r, if it's equal to null, then it's not full. And so then it's not complete as a result. So then we want to return false. We'll call this complete and valid. Okay, so I guess that begs the question. Let's make one that says complete. So this is just going to test whether or not the board is full. And then finally, we'll have complete and valid. Okay. Do a check for completeness. I think, actually, I'm not going to check those. We'll just leave it at that. Okay, so there we have a solver that's now able to check whether a given board is a valid Sodoku board or whether it breaks any rules and whether it's complete or not. Those are the checkers that we need in order to do our recursion. So we'll come back doing our recursion in a moment.